HVAC 360, episode number 6, Smart Chillers. Welcome back, everyone, to another edition of HVAC 360. I'm your host, Matt Nelson. This week, we're going to listen to an interview I did at the 2010 HR Expo in Orlando, Florida, with Jeremy Ouellette of Smart Chillers. That was a great chance to actually go there and see and touch and feel a smart chiller. If you have never seen a smart chiller or a turbo core compressor, that was really a great opportunity to get up and close and personal and actually get to see one of those in cutaway and actually in operation, as we'll kind of find out in this interview. So without any more details, we're going to step it up and let's go back down to the HR Expo floor. All right, we're here with Jeremy Ouellette from SMART Inc., talking about the Smart Chiller and the turbo core compressor, which is a basic component of that chiller. So, Jeremy, can you explain a little bit about the theory behind what the turbo core compressor is and what it does and how it operates?
Sure. The compressor is basically it's basically a standard centrifugal, smaller and without oil and magnetic bearings. What the magnetic bearings allow is they allow for no wear over time on the bearings, and they allow the compressor to use very little energy in the bearings as far as for use over time. The compressor spins at 10 times the speed as a large compressor and is able to achieve sound levels that are basically lower than even a standard water pump in the plant room. Right now, the compressor is running beside us, and we're still able to talk and carry on a normal conversation. Right.
We'd be able to touch the compressor if we reach our hands. We're that close. So, as far as maintenance goes, it's a very low maintenance item.
It's extremely low maintenance. The only scheduled change-out maintenance on the compressors is actually the capacitors, and every 10 years the capacitors need to be changed, and it's usually 1 to 2% of the total chiller cost for the scheduled maintenance, as opposed to a partial or full teardown on a standard centrifugal or screw chiller. It could be as much as 50% of the cost of the chiller.
Now, what kind of capacities are we looking at? The increments that are available on the chillers.
Sure. Well, Smart's full range of chillers uses from 1 compressor up to 6 compressors on a single barrel. So we're able to make chillers as small as 60 tons and as large as 1,000 tons.
Okay. Now I see we have 2 different varieties. You can have the water-cooled indoor chiller, and you can also have an air-cooled outdoor chiller.
That's right. The air-cooled chillers is a bit more unique. We're the only company in North America that manufactures an air-cooled chiller with the turbo core compressor. The range of the air-cooled chillers for us is 60 tons to 250 tons. We actually couple the variable speed compressor with variable speed fans to allow seamless modulation over its use during the day.
And that's all internally controlled?
Absolutely. It's all internally controlled. And actually, what ends up happening is the sound level on an air-cooled chiller is for us mostly linked to the fan sound level. The compressors are so quiet that in an outdoor environment they're essentially noiseless. But the fans, because they're variable speed, the perceived sound without fan staging, they're just slowly unloading, is much lower. So if you're in a residential area, say a school, in the evenings the fans are 95% of the time running at 50% or lower and varying their speed slowly, that it's almost impossible for the ear to pick up.
So when somebody starts designing for a turbo core compressor chiller type smart chiller, what are some of the things that they have to keep in mind? What are some of the important design points?
Well, there's a few. It doesn't solve 100% application. If low chill water to make ice is at the edge of the operating bounds, it's possible, and we have done it. But it's important to get the right flow rates and the right temperatures, or else you'll be outside the bounds of the centrifugal. Also, because it's a centrifugal compressor, it speeds up and slows down at a certain rate, and that rate is 10% per minute. So it's important to have enough water in the system to allow the chiller to ramp up and ramp down. And that's not different from any other centrifugal, but it's important to keep in mind.
Okay. Now, as far as in the past, some of the problems that I've heard happening with the turbo core compressor was that it's very susceptible to vibration or seismic shock. Like if it was not on grade, there might be some issues. I know that they resolve that right now, and pretty much the installation base is rather smooth.
Yeah, the compressors themselves are extremely intelligent, and if there's any sort of external vibration, the compressors will pick it up and they'll turn themselves off in order to protect themselves. And then when the vibration would stop, the compressor would sense that and would start back up. We do not require isolation springs on the chillers. They can be placed strictly on neoprene pads because they don't put vibrations into the building, and typically vibrations from the building don't hurt the chiller.
Excellent. Now, do you think there's anything else that we haven't covered here?
Yeah, SMARDT manufactures in Montreal, Canada. We have a second factory opening in New York. Over 60% of all of our components actually come from the United States. The compressors, all of the copper, and the shells for the heat exchangers. This actually makes each chiller more than 60% component U.S. made. So we actually do, even though we're a Canadian company, we will have a manufacturing facility in the United States to meet Buy America.
So the refrigerant that it uses, what refrigerant does it use?
We exclusively use 134A. 134A is currently does not have a phase-out schedule, so it's a lead-friendly refrigerant, and we're happy to use it in all the chillers.
Now, what are some of the things that are up and coming for the smart chillers in the future?
A few things that are up and coming. On the stand today, we have a new TT350 compressor. It's a 110-ton air-cooled compressor. It's a larger compressor that's just been unrolled. We're the only company we're the only turbo core customer that's actually using the compressor, because we're the only company that has a air-cooled chiller that can use the compressor. Also, across from it, we have a water-cooled chiller that is seismically certified for hospitals in California. That, as of 2010, all the hospitals require equipment to be seismically certified. So we're happy to supply them with that sort of equipment. And that's short term. That's what's coming out.
Okay. So now, when we talk about cost, what are we talking about? Ton per ton for something that's a comparable size chiller. What sort of percentage are we talking a premium in dealing with a smart chiller?
Our philosophy is strictly our philosophy for chillers is oil-free centrifugal compressors. The whole range is built around the compressor. Because of that, our design philosophies at 60 ton and 900 tons or 1,000 tons are the same. But competing chillers have different competing models in that whole range. So the smaller chillers are typically screw compressors or scroll compressors that are a bit cheaper. We're typically more expensive by, say, 30%. But in that range, we're also 30 to 40% more efficient. So if the chiller is going to have extremely low run hours, it's going to be difficult for the owner to justify the cost. However, if it has any sort of run hours over 1,500, then it makes financial sense. The larger chillers, we are typically between 10 and 20% more expensive. But in the larger chillers, we will have more compressors, which means internal redundancy, and there's a premium to be paid for that. So redundancy as well as still an efficiency game at the larger tonnages.
So if you have multiple compressors on a single barrel, and one of the compressors goes down, how does the system work?
The system keeps on going. If a compressor fails, the other compressors. If one compressor goes down that was running, another compressor would come online to take its place. That compressor can then be isolated, refrigerantly isolated, and electrically isolated, and be removed while the chiller is still in operation. So the chiller does not have to see downtime when a compressor has a failure.
Excellent. Now, what about the air-cooled chiller? I mean, as far as cost comparison goes.
Well, we find actually a larger gap in the air-cooled chillers, but we also find a larger gap in efficiencies. What ends up happening is, because there's no oil in our air-cooled systems, our centrifugal compressors on the air-cooled can ramp down to a very low pressure ratio. This allows the compressor to draw very little power. Coupled with the fans that draw very little power, affinity laws and the fan laws state that power is the cube root of the speed. The mix of that leads to extremely low efficiencies at lower loads and lower ambience. This makes the average efficiency of the air-cooled chillers much better than the competition that has oil in the system and needs to keep these head pressures elevated and pressure ratios high, and it isn't able to take advantage of lower ambience.
Excellent. So essentially what we're saying is, as far as the cost goes, it really depends on the application and the size selection based on the more typical models. So that you could find a sweet spot where the smart chiller would be, right in line with an existing product, or could even be better, more cost effective, and even possibly, depending on the requirements of the project, be a better fit for what you have.
Yes, and it's really that's really dependent on the type of buyer. We find that building owners that are looking to switch over buildings quickly typically don't want to spend extra money on the efficiency of the chiller. However, they could turn it around and use it as a selling advantage and increase the price of the building, knowing that the electricity cost for the year will be lower. And also, that delta, the delta in efficiency of the air-cooled, it's substantial. It's pretty easy to state that a 50% energy reduction is seen in the air-cooled chillers compared to not just an existing air-cooled, but the next a competing model's highest efficiency chiller that's new on the market.
Mm-hmm. Now, is SMART only involved in new chiller applications, or do you get into retrofit applications?
No, actually, SMART has a retrofit division. It's called SMART Retrofit Solutions, and we supply contractors throughout the United States with compressors to do retrofits on existing chillers where the heat exchangers are still usable. We don't promote waste. So if there's positive heat exchangers that can be used, we do that, and that's been up and running now for about a year, and it's a very successful business.
Now, is there any when you're doing a retrofit application? I don't know if you're familiar at all with it, but as far as the good candidates, I mean, is there a good candidate and a bad candidate? I mean,
there absolutely is, because what you have to look at is, it's a price premium almost every time to use a turbocore compressor, but for that price premium, you're getting. You're not getting a 1 or 2 year solution. You're getting a 20 to 30 year solution, and typically that solution is the expiration of that solution is based on the weakest component. The compressor in every situation will not be the first component that will fail. Therefore, if you're doing a retrofit on old heat exchangers, if those heat exchangers are going to fail in 3 years, then there's no point in putting a 30-year solution on a 2-year problem.
So now, I guess, where are the smart chillers commercially available?
Well, we actually have a representative network throughout the United States. and we're in every major market. We're competing in on every. We're competing all over. We consider ourselves the 5th largest chiller manufacturer in the world, and the largest turbocore compressor chiller manufacturer in the world. Most consulting engineers at this point have heard of us and have our catalogs and use our equipment when appropriate.
Excellent. Well, I appreciate your time, Jeremy. All right. Well, I'd just like to thank Jeremy for taking time out of his busy schedule there on the expo floor to take the opportunity to talk with us. In retrospect, I really thought it would be a great idea to be next to the smart chiller while I did this interview. I don't know if it turned out as well as I thought it would. I mean, it's amazing that we can stand that close to one of those smart chillers and not really have anything, extraordinarily annoying. But I mean, to be that close to a piece of mechanical equipment and not have, really, standard chillers, if you haven't been around them, they really scream. I mean, we could not have done that with an ordinary product like a centrifugal screw chiller or a centrifugal chiller or a screw chiller. I just combined chillers there for a second there. But it is that quiet that we can actually have a conversation. However, the downside is there was still that whine that I guess if you're listening to this in a pair of earphones, then I apologize. I think in retrospect, it probably wasn't the best thing to do. Maybe just to kind of have that to go up close for a couple of seconds probably would have been plenty to kind of prove the point home, as opposed to standing there during the entire interview and talking with Jeremy there. So, well, that pretty much does it for this week. I appreciate all of you listening. If you like the show, why don't you let your friends know, share the link, tell them about HVAC 360. If you would, you can follow me on Twitter. I'm at BuildingX. Or if you just want to drop me a line, have a show suggestion or a comment, you can either do it on my blog at buildingx.co or send me an email at matt@buildingx.co. So, until next time, remember, know what you build and share what you know.